Hey guys, Jimmy Sauce Alex here. Today we will be talking about how to minimize costs using multiple inequalities. So, our example problem today is, Shorecrest will be traveling to Benaroya Hall for a prom. Your task is to find the most cost-efficient way to do this. You are in charge of transporting a minimum of 240 students to the prom. At your disposal are limousines and cargo vans. Each limousine holds 8 passengers, while each van can carry 20 passengers. The cost to contract a limousine is $400, and the cost for a van is $550. There are only 18 drivers available that night. How many types of each vehicle should you use to minimize the cost? For this equation, we will use X for limousines and Y for vans. We will have a couple of standard inequalities. One of our inequalities is 8x plus 20y is greater than or equal to 240. Another is x plus y is less than or equal to 18. The last two inequalities are x has to be greater than or equal to 0, and y must also be greater than or equal to 0. Okay, so for the inequality 8x plus 20y is greater than or equal to 240, that shows that you must carry at least 240 students to the prom. For the inequality x plus y is less than or equal to 18, shows that there are only 18 drivers available that night, so you have to have less than or equal to 18. The last two inequalities are real-world inequalities. For these, you can't have negative limousines or negative vans. It's just not possible in the real world. For the first two inequalities, x is greater than or equal to 0, and y is greater than or equal to 0. Those are just the x and y axis, which means that it has to be in the top right quadrant. For the next inequality, 8x plus 20y is greater than or equal to 240. We just used standard form to figure out the line and its slope. Inequality. X plus y is less than or equal to 18. We once again use standard form to figure out the x and y intercepts and the slope. The place where the two feasible areas for the feasible regions for the inequalities overlap is the possible answer zone. The feasible region has 3 points that are a possible solution: A, 0, 12, B, 0, 18, and C, 10, 8. We can use the distance formula to find that the closest point to the origin is C. Because X is limos and Y is vans, the most cost-effective solution is 10 limos and 8 vans. As easy as rustling your Jimmy. Thanks for watching Jimmy Sauce.